Hello, good evening, good morning, good afternoon, welcome, bienvenue, wherever you are. Remember, keep your hands inside the car at all times. Here we are, we've got really quite an amazing lineup this evening. From right to left, I think it is, as you see it, we see Dr. Gregory Kretzinger and John Chavini. Then we see Joseph, I forgot to ask him how to say his surname, blast. Aletkyand, there we go. He reminded me, Rory Paul, and then Stu Townley there at Flying Intelligence. So, hi, one and all.
Evening.
How do? So, Rory, let's kick off with yourself first. You have been not quite guiding me, but you are my ag mentor, if you will, and I am still trying to row count with a Phantom 3 professional, and I'm going to run into trouble because all of the crop, even though it's coming out at on different weeks, planted in different weeks, all of it's going to be too high soon. I'm really struggling. Where am I going wrong?
Gary, so first of all, like I said the last time we spoke, I'm really impressed with what you're doing and putting this out in the general public. So before we came on air, I admitted to you that I have never really attempted to row count or the way that you've done this. So whenever we counted crops, we were always going for a sample area, and we were using a slightly a higher resolution camera in all cases compared to the GoPro 3. So starting at 12 megapixel and then now a 20 megapixel camera. And what we simply did is we designated areas in the field and we took sample imagery, calculated the area from the row spacing and the plant spacing, and then did a small sample in each case, and then went back 2 weeks later to the same area and did it again. So while I've been doing this for a while, we've never attempted to actually count every plant in a field. So what you're doing definitely probably has been done. I don't think that this information has ever been shared before. So it's very interesting.
Well, I think what I'm one of the main problems I'm running into is that if there is any wind, then that crop is blowing in the wind, and that's going to change the image ever so subtly as the aircraft is going up and down. And because the algorithms demand such precise or high resolution, 1 to 1.5 centimeter per pixel resolution, I just think there's too much change. And so far, I don't think it's working, but it could be because I'm doing something completely wrong. I absolutely can get that. And also, the terrain is real terrain. It has altitude and it has curves, and so the resolution on one side of the field is completely different to the other. And I think that's throwing out the algorithm. So I'm just wondering, it's making myself think, have we seen loads of ag data from flat fields in the Midwest where you are, and we haven't seen ag data from the real world, which is bumpy?
Okay, so yes, and this is part of the problem with the sector itself. So in a lot of instances, these applications and algorithms have been developed in academia for test plots, but they've never really been rolled out to large-scale production areas. Now, with regards to your changes in topography, so I think if you were using a different mission planning software that could take the undulations into account, you may have better results. I'm not familiar with Drone Deploy's planning software, but things like universal ground control, etc., claim to have the ability to adjust for topography. So that might be a route to try.
What height were you doing that, Gary?
Oh, well, yeah. Oh, I know what you're doing. I know what you're doing. You're bringing me back to last week in a particular incident when I changed it from 22 meters to 20 meters and discovered my estimation of the height of trees was not correct. No, yeah, about 20 meters, 22 meters, because that's what the software tells me it needs to get that sort of a resolution. And that's not a great height to be flying. I'm sure the sensor is key. and it may not quite be up to it.
So Gary, the sensor on the Phantom, is that a 5 megapixel?
Four megapixel. Well, no. For stills it'd be 12, I guess. 12. Yeah, I think it's 12. So it's pretty good, but you've got the what's that, rolling shutter effect, haven't you?
Yeah.
And that's not the best. And the Phantom 4 Professional apparently gets rid of that, so that might be better. But I still think it's a big ask for the thing and for the software. And time will tell. The flight planning element of it in Drone Deploy, I'm very impressed with, and all of the others. They're all very good, and they are only just ways. All of these apps are just ways of snaring you into whichever ecosystem those people then use, whichever the post-production is afterwards, and they're all very good, and it is amazing compared to 5 or 10 years ago. It's quite extraordinary that you can flight plan as easily as you can now. So that's out the way. So maybe it's just now the claims of what it can and can't do that's a bit worrying. I think I would like to start seeing from these companies examples of mapping in rural England, which is bumpy, rural South Africa, which is very, very bumpy, and rather than flat places. Let's have no more flat places in these things, and let's see what happens. And one of the things I would like all the apps to do, which is a bit, because I'm an old duffer, I really like my quad to, when it comes back, to turn around and face away from me, so that the control directions remain useful. Right is right, left is left. I'm sure, I have a hunch that there's a lot of crashes out there involving these apps. Oh, look, it's Christmas now. How's it, Bruce? It's excellent. Because they come back and the thing's facing you when they come back. I know it's a silly little thing, but I reckon a lot of people crash because they don't manually fly. For some reason, they've got to then manually fly. The thing's facing them. Good night, Vienna. But anyway, that's just me.
Gary, can I just ask you, which software did you favour then to do your test flying on it?
I like Drone Deploy, and the reason I like Drone Deploy is because of the silly little check. Well, I won't say silly, but they have a little checklist, and it says, is your camera ready? Is the SD card ready? Have you got enough satellites and stuff like that? And that little pause, in actual fact, is quite clever, because it gives you those few more seconds for the GPS really to sort itself out, and for everything to be tickety-boo, and away you go. Too many people just rock up, hit the go, and the GPS still waking up, but it'd take a while to wake up. They've got a lot of work to do, and so I like it for that reason. It slows me down and it makes me think before I fly, because it has a checklist that runs down through the points. The other ones are okay, slide to take off and things like that. I don't know, I find that a bit naff. I don't know. Well, what do you use, Stewie?
I use Pixel D and I absolutely love it. Pixel D goes through not so much of a detailed checklist, but it certainly does go through a checklist. It'll give me a manual override if I'm outside 150 meters from the center of the grid, and I've had no problems with it whatsoever. It's really good, nice mission software. The only drawback is, of course, every mission has to be in a box mission. So you tend to find then, if you're on, be it rolling ground, as one does learn the hard way, you obviously do the highest and work down lowest, be it there as thin strips or however you want to do it, But what you don't want to be doing is mixing high ground with low ground, because as you're finding there, your resolution level drops down significantly. But time in, time out, getting 2 centimeter pixel resolution.
Yeah, but that wouldn't cut it with this road count. With none of the guys that advertise road counting, that wouldn't cut it. No. Sure, terrain following will come in a big way, and it will come soon. And other fixes, but at the moment, I think these promises are too much. And when we speak of promises, I think, Rory, you're a little bit worried about what is being promised to people, and then the end product people are producing, and how that works.
Yeah, so this is a topic that I'd like to share with the forum and get some input on. So here in America, we have, every state has professional associations. So for example, surveyors have a professional association. And a lot of instances, they have, over the years, got laws passed at the state level that protect their professional qualifications, etc. So, for example, you cannot produce a map and call something a map unless you belong to a surveying professional society and you've been certified by them, or a civil engineering society or photogrammetrist society and actually been certified. And the penalties for actually breaking these rules can be quite severe if you get caught. So this, started me thinking that companies like Kespri and Skycatch and even Drone Deploy that are basically enabling a set of individuals that aren't necessarily qualified to generate what they are generating. And it's only a matter of time that somebody is going to run afoul of these professional associations, and they're going to come down on individuals that are producing maps or digital terrain models, or et cetera, et cetera.
But isn't this a Silicon Valley? Sorry to interrupt you. Silicon Valley thing where technology will make everything else get out of the way, or make the old stuff get out of the way. Get out of the way, says technology.
I think it will eventually, but in the meantime, there are going to definitely be fatalities and injuries, financial ones, to people that go out and purchase or lease a Kespri or a Skycatch, whatever it is, and go to work, and then find themselves facing a lawsuit because they are not actually qualified to produce the product that they're claiming, that they're producing.
So whose responsibility is that?
Well, I don't know. So I think that there's a shared responsibility. And there's another little sideline to this. All these lease service options out there. I ran across a gentleman that is actually qualified to produce the maps because he's a surveyor. But he's actually currently, and I'm not going to say names, etc., he's currently breaking FAA regs, and he's flying across Bravo airspace without a waiver. And I can't help wonder what the liability is for companies like Kespri, which are basically enabling, or Drone Deploy, etc. I don't know if they've got some limitations that keep you out of restricted airspace. But what's going to happen when these individuals are caught? Does that liability flow all the way to the hardware supplier, the service supplier, etc.? These are just thoughts.
Well, I guess sorry, Stu, after you.
But the argument then could be General Motors, they make cars, but at the end of the day, they don't offer driving lessons. So,
Yeah, but unfortunately, in this case, this is very similar to robotic vehicles. It's going to be, if I go to Drone Deploy, or let's say Kespri, okay, and I use their software to perform my mission planning and then execute that mission in Class B airspace, okay?
Mm-hmm. Yes,
yeah.
So you're saying the mission planner, the mission planner shouldn't let you do it right out the get-go. Luckily, we've got a tame lawyer in the middle there. Tame lawyer Jonathan, what thoughts have you?
How's my audio coming across? Is it coming across clearly?
We can hear you.
All right. Okay. So I was someone posted on the forums regarding unlicensed surveying and stuff, and I found the article they were actually referring to. And there was a board action in North Carolina, and in the discussion of the case, it said the board issued a letter to place the company on notice that practicing or offering to practice engineering and surveying in North Carolina without being licensed with the board is in violation of, and it gives citations. This includes location data, dimensions, and quantities that are issued for an authoritative purpose to be relied upon for the data or stated accuracy. The activities that may meet the test include but are not limited to 3D laser scanning, as-built drawing creation, 3D modeling, underground utility mapping, stockpile volume calculation, void volume calculation, and GPS mapping services, and more specifically to engineering. And it kind of gets more into it. So this is a big problem that's been popping up, not just in North Carolina. Patrick sent out a letter that I don't know where he got it from, a person that obtained a cease and desist in California. They were doing some type of surveying as well. So that's a big problem now for the end users now regarding the drone companies that are providing these services. It's going to be a little bit harder to try to get them for somehow collaborating with these guys that they're doing some type of unlicensed surveying. What will be interesting to see is the potentiality of lawsuits that come down the pike if a drone does actually impact an aircraft of some sort, and there is a lawsuit. And because the big problem is just how are you going to determine who was flying that aircraft and really what aircraft was it? And so then the closest thing that comes into my head is like asbestos litigation, where they don't really know who was the actual installer of the asbestos, who manufactured it. So what they end up doing is they sue all the asbestos manufacturers, and then it's kind of based upon market share. So I don't know if that's going to somehow creep its way in over time regarding these apps that either do or do not restrict the operator from flying in certain locations. Because if they do restrict the end user from flying in certain locations like Bravo, Charlie, Delta, Echo at the surface, then that sets you up for a better defense, saying like, well, our software says no, so it's probably not us. It's probably somebody else's stuff. It's some other end user. The only one big downside to that, though, is now you end up losing potential business from people who need to operate in those areas. I mean, prime examples like the DJI situation. If anybody wanted to operate near certain airports, you have to go get an unlock code, and so there's an extra bit of hoop jumping there that you have to go through. So there's pros and cons to this whole mess.
So is this the new FAA issue? I'm not saying that very well. Is this a new issue? Is this, okay, 107's arrived, so that's the FAA squared away. So are traditional industry going to start getting in the way of this new industry, do we think?
Yeah,
they are, because for the traditional surveying boys and what have you, they're now becoming angry because drones can cut in half the delivery time on surveying projects and so on. So they're saying, you go and put your $1,000 membership on the table, and then we'll give you a green light. And that's what it's all bloody about, isn't it?
Yeah, no, well, I fly with surveyors here, and the thing is that they're laughing at my crop counting thing because they know their stuff. They know their stuff, and a surveyor brings a lot to the table once you've got a drone. You can't just go and buy a Phantom and think you're a surveyor. You just don't have the skills. You do not have the skill sets, and it's a lot of work. But that's ranting on a bit. So can we predict for 2017 then that these sort of traditional associations are going to be getting in the way?
Yes.
Yeah, I think that we're definitely going to see it here in the States, because while it might be difficult to pin down the UAS operator legally, that's not going to stop them from trying, because as we know in America, you basically take them to court and you let the judge decide. So we're going to see. I honestly think this is going to be a new hurdle now, especially for the larger service providers.
Well, also keep in mind that the problem. Okay, like let's take the flip side of this. Is it's similar to like what goes on in any of these like kind of professional service type of situation, even like with lawyers or doctors. What happens is then when you kind of go, hey, we don't like the law, and you push back, let's let everyone come in. There ends up being a lot of people who end up getting hurt by people who really rely on what they read on the internet, some app or whatever, and then they do harm people. And so when you actually go after them to sue them, what happens is those people don't really have a lot of money. They probably don't have insurance, and you, being the stupid person that didn't do your due diligence on these people, end up having really no recourse because you don't have debtor's prison where we just send them off to jail. So some of these laws, like unlicensed practice of law, unlicensed surveying and stuff, they do have a kind of like a criminal component to them. Some of them do in some aspect. And so then that as a, regardless of whether you're broke or not, you can go to jail broke just as well as going to jail, right, with money in your pocket. And so there is some level of kind of like setting a standard to protect it, but at the same time, there are a lot of people trying to protect their turf that they've invested in, and so the surveyors are going to try to keep that advantage. So I understand that there's pros and cons to both sides of the argument.
But it's something to watch if you're starting a Part 107 company, is make sure you are correctly licensed. Or I should imagine you employ a surveyor or something as part of your team to legalize what you're doing, as it were, wherever you are in your part of the world. Now, joining us on your right, on everybody's right, I think, is Bruce down there in New Zealand. Very festive, a little bit early, but then New Zealand is that bit further ahead. You are speaking to us from the future. Or not at all, with the microphone off.
Yeah. Yes, it is the future. It's tomorrow. Yeah. And ho, 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 Merry Christmas. Who wants a pony? That's my job. This week I'm consulting with Santa for drone delivery of gifts around the world. So, yeah, stay tuned for that.
Pigeon pie in the oven already?
Pigeon pie?
Pigeon pie?
Yes.
Well, I mean, I haven't. You've just made me think we are going to get inundated with Santa drone delivery stories this year, aren't we? I hadn't thought about that. This is and it's your fault. Now it's officially your fault, actually, Bruce. It is your fault. Now, I've heard you like lurking around parks at night, and you're the man for that. So, when you're lurking around in parks late at night, what piece of equipment would you use to enhance your experience?
Well, I just reviewed the RunCam Night Eagle camera, which is a really impressive low-light camera. It's not a night vision, it's a low-light camera. I think was 1 millilux or something, maybe 100 microlux of illumination required. It is actually really impressive. The video's on my RC Model Reviews channel. But it brought up an interesting issue with regard to the regulations here in New Zealand, because you can fly at night, FPV, drone at night, as long as you operate in what's called a shielded operation, which means you've got to stay below the level of the trees so you don't bang into aircraft. But under our laws, you have to have an observer, a spotter, whenever you fly FPV. But the problem is, if you're flying at night with a highly sensitive night camera, then you see better than the observer. So what is the observer's role? And I've put this to the regulator. I'm going to be very interested in their response. What is an observer supposed to do if you're flying at night and they can't see a damn thing and you can see better than them?
Yeah, I thought that shielded operation thing that you mentioned in your video was very interesting. And I've not heard of that before. So can you just run through that definition if you have it in your head?
Yeah, in New Zealand, because our regulator didn't want to distinguish between commercial and non-commercial operations, there's no difference at all between a commercial and a non-commercial drone operation. So what they've done is they've tried to make regulations on the basis of risk. And one of the issues we have is that it's a small country, we've got a lot of airports, and you cannot fly within 4 kilometers of an airport. So if you didn't provide some facility for operations near an airport, then there'd be very few places you could fly here. So what they did was they said, quite sensibly, if you're flying below the level of something like trees or a tower or something, and within 100 meters of that object, you're not likely to encounter a full-size aircraft. So therefore, we'll call that a shielded operation and allow you to do that. So it means if you go to a park and you stay below the level of the trees, it doesn't matter if there's an airfield right next door, there is no way you should encounter a full-size aircraft, so you can fly your craft. And it works out pretty well, but there are some anomalies, as I said, because we have the other problem that you can't fly anywhere without permission of the landowner, which means that when tourists come to this country, all our lovely, splendid scenery, they can't fly their drones unless they find out who owns the property and get their express permission. And it's kind of, so they give with one hand and take away with the other. But I think more countries should consider the shielded operation thing, because it makes no sense to restrict someone's flying operations if they're flying, like these racing mini-quads, flying through a forest. I mean, where's the risk to the national airspace?
Yeah, no, absolutely. I think it's a great pity that it seems to have, FPV racing seems to have moved away from the forest flying, because that is the most obvious risk mitigation there is. You pull up, you hit a tree. It's so obvious, it's ridiculous. That's very cool that you have that. Isn't there a town down there? Maybe it's your town. Isn't there a town down there that does allow or has said, come one, come all, come fly your drones here and your model aircraft? Isn't there a more friendly town, or did I make that up?
No, there was a town in New Zealand called Aletkyand, I think it was, which declared itself to be drone friendly, because when the new regulations came out, most of the councils in the various towns were left on the back foot. They didn't know what to do. They had to do their research and health and safety and all that usual stuff. But Aletkyand acted very quickly and said, we don't see a problem. These parks and reserves are owned by the people of the town. They have a right to use them. So as long as you're not endangering anyone or, invading people's privacy. You can use our parks for flying your drones. It was brilliant, excellent. Unfortunately, the town I live in says, you can't use the parks and the reserves. They're only for looking at.
Fair enough. That's way. That must be your fault. It must be something you did. It must be something you said. Must be. I saw a very interesting.
Logic doesn't apply because every year in this country, there's I think 12,000 people are bitten by dogs. But you can walk your dog in the park, but you can't fly your drone, even though there's never been a single reported instance of anyone being injured by a drone.
And very few bitten by them as well, in fact. I saw an interesting thing about down by you about reclaiming land and a big environmental push that was happening, and that seemed very, very, very cool. And it, of course, makes me then think of unmanned aircraft and the role they might have in that. And I noticed just as I start trying to run into the guys from here he is, he's back, John's back. We're very lucky to have the guys from Parrot, and Parrot have so that's Dr. Gregory Cutzinger and John Chimini, and they've announced today an environmental initiative. So perhaps, chaps, you'd be so very kind as to lead us by the hand through that.
Yeah, John, do you want to talk about the project we did, and we can talk about the grant that came out of it?
Yeah, what was interesting is we had always kind of done vegetative indices in 2 dimensions. And one of the things that we had always kind of thought in our head and talked with the folks at Pix4D was, how do we take these vegetative indices and bring them into 3 dimensions? And basically the answer from Pix4D was, we don't have the right data set to experiment with that yet. We were lucky enough to be able to bring Greg on board at Parrot, who had some great contacts within the UC system, who has effectively a crown jewel of California in their reserve system, which is a number of very large natural reserves within the state of California that are spread across various ecosystems. And one of them is right outside of Sequoia National Park in Kings Canyon National Park. And there are a number of very large sequoia trees there that are very well mapped over the last 10 years, 15 years. And they're mapped by hand. So we have guys and gals shooting crossbows and ropes into trees and climbing trees and measuring branches by hand with tape measures and measuring from branch to branch, and then measuring circumferences of branches, and then basically creating calculations that estimate biomass of leaf mass based upon the diameter and size of those branches to calculate CO2 sequestration. So it's a very well-established way of measuring CO2 sequestration through these forests. And what we wanted to do was try and figure out how we could take new technology like aerial robots and advanced sensors like Sequoia, who are shooting RGB and multispectral images at the same time, and advanced processing software like Pix4D, and see if we could correlate the measurements that we get out of Pix4D and the biomass estimates of the vegetation that we see in those point clouds to the measurements that were done previously by hand from the scientists that have been measuring these things for decades.
Yeah, so essentially on these trees, we have a wireframe of these trees that have already been stitched together kind of by these hand measurements with tape measures. How do we drape over a multispectral image and interpret that to say, okay, how much leaf area is there? How much wood is there in these trees? And how do we use these different measures that we've typically thought about in 2D and 3D? And the answer is right now, like, we don't know. It's going to take a bit more ground truthing and trying to figure out what are the correlations between the multispectral measurements. How do you do volumetrics on 3D multispectral data? That's pretty new to the world. But what came out of this project overall was this idea of thinking about, hey, you know, drones are a new tool, and They're innovating in 2 and 3 dimensions and multispectrally. Let's put it out there to our community and think about how we can promote this new tool and drone data and multispectral data to the research community at large, particularly as it relates to climate change. And so we've opened that climate change innovation grant up to worldwide to a broad audience.
It all looks amazing. Just explain, just help me understand why the spectral data isn't 3D whereas people tout RGB stuff being three-dimensional. I'm not understanding that, but where's the jump or leap or change there?
Yeah, so when you have it, some of it has to do with the physical distribution of the cameras. So you have cameras that are physically separated, and so you don't have individual points that overlap 100% because of that separation. And so what we've had to do, and what Pix4D had to figure out, is how do you take an average of multiple points and create some kind of ratio like an NDVI in 3 dimensions. So it's essentially taking an average of multiple points that then become an NDVI value, but then can be distributed in 3 dimensions. So what that means, though, for how much carbon there is, remains to be determined. That's kind of the next step of our project and our collaboration. Whereas an RGB point can generate a point cloud, here you're taking multiple data layers that have to overlap exactly in order to get a ratio. If they don't overlap exactly, then you're going to have to figure out a different way to take the average of those points.
You're combining reflective bands, right? So you're creating effectively a 3-dimensional map of a single reflectance band, whether that's red or red edge or near infrared or green or whatever, and then creating that ratio. And as soon as you create that ratio of combining reflectance bands, it becomes more difficult, right? And so that's what was kind of the new innovation that we were able to drive here.
So the Sequoia sensor has what does it have? Does it have five sensors in it in RGB and the others? And it also has that you put on the top of your aircraft a sensor that detects the ambient light. So perhaps in my crop counting little games or playing around with that might help me when the light changes across the field. I generated a lovely map of stripes of the sun going in and out of the cloud the other day just with RGB. So can you just explain quite how the Sequoia works? I suppose I ranted to get to that.
Yeah, so as the camera triggers, you get 4 TIFF files, one that lines up with each band, red, green, red edge, and near infrared. And then you get a JPEG RGB file that's triggered all at the same time. Well, the light sensor has 4 on it that correlate with those individual bands. As it triggers on that TIFF file and the EXIF data of that TIFF file, it records the light data for that particular band, the wavelength of light of that particular band. So in post-processing, then you can calibrate your image based on what the light availability is. Is that a good explanation?
Yep.
You think, John?
Yep.
So you get you trigger, and then you get the light data tagged onto that particular photo, and you can use that light data then to calibrate if you're flying on a cloudy day or a sunny day, etc.
And the advantage of that, Gary, is being able to compare results over time, right? And so that's what really gets interesting is how can we compare results in different lighting conditions over time and have them correlate to each other.
And in vegetation, that's important for all sorts of time series data, whether it's the phenology of how the plant is growing, whether it's the spread of plants over time, whether that's disease outbreaks that might occur. So that time series data within a growing season and across the growing season are pretty fundamental to understanding how vegetation dynamics are occurring.
How critical are GCPs in measuring the Z?
Yeah, fairly fundamental for some aspects. If you're trying to compare the same plants from one day to the next or 1 month to the next, and you're off by centimeters to meters, then you're not going to be able to have that accurate time series data. But I'm finding a lot of times that it's not actually a stitch that you want to look at for some aspects. You want to count every flower. It's better to look at the original JPEG photo of that particular plot than a stitch of photos that's kind of an amalgamation of different directions pointing and the wind's blowing, etc. It's better to go back to just an initial snapshot and go out there and count every every flower that might be in there.
There's a lot of interpolation happening, right? Regardless of any orthomosaic you make, any three-dimensional model you make, you're interpolating data, right?
Yeah. And so you're never going to replace boots on the ground going out there to, so my background's in ecology. That's what my PhD is in. And I take a square of PVC and I set it down out in the field and I count everything that's in that PVC. Well, sometimes doing the same thing with a drone with one picture and trying to count everything in that picture is better than trying some high-tech method that's trying to, quantify everything autonomously. Well, sometimes there's some low-hanging fruit in there. But in this case, what we're trying to do with 3 dimensions is actually say, okay, now we have a point cloud overlaid with multispectral data. What does that actually mean? And we're only beginning to understand what that means. And so we're pretty excited about the next year or two as we try and really ground truth, combining point clouds and multispectral data together. That's pretty cool.
John, can I just ask a question quickly?
Yeah, of course.
Okay, when it comes to the sequoias, and I don't know how they're structured, when you're looking at vegetation, density, etc., how do you account for foliage that is obscured by an outer layer of foliage?
Go ahead.
So, it's a 3-dimensional object, and you might have leaves that are obscured by an outer layer of leaves, wouldn't you?
Yeah, exactly. And that's what we're trying to understand with comparing the data that we're gathering from effectively an aerial vehicle on the outside of the crown of this tree to the data that the researchers have already collected from the inside of the tree by climbing it on the branches. And they'll take a branch, they'll measure the whole thing, and then they'll strip all of the biomass off of that. They'll weigh it. They'll determine the density of it, and they'll create calculations that they can then apply to the other branches within that tree, right? And we know that we're only getting a certain subset of the outside, but is there a similar calculation that can get us to a similar level of error rate?
So in other words,
you're
pretty much sort of sense checking it then for the moment then?
Yeah, so, we know that a branch this big around and this distance has this much foliage. But if we measure it from the outside and say, well, we know this outside has this much foliage, how do we back calculate and how do we fit those data sets together so that eventually we can just survey from the outside and try and do back calculations for leaf area or biomass or the amount of wood or the amount of carbon. I think that we still have a ways to go before we get there, but the unique aspects are that these trees have been mapped in a wireframe with no foliage mapped on the outside, and now we're coming in with a drone and mapping the outside, and we can combine the data sets and work together to be innovative there, and that's what we're trying to get to.
I think it's fantastic. It is. Well, it's why I got into the game, was for environmental stuff. But that aside, let's just touch a little bit more on the Sequoia sensor. So it's got a GPS on board, it's got IMUs on board, so it knows where it was, it knows which way it was looking when it took the shots. And so if I want to put it into another platform, all I've got to do is give it power, really. I see you're using a Solo in this survey, and you have an adapter for that, and you have adapters for various DJI gear as well. But basically, if I want to put it in a platform, I just power it, and then it carries on and does its own thing. It knows what it was doing. I don't need to do anything more than set it up in software. Is that right?
Correct. All you need is 5 volts at 3 amps, okay? And then it basically boots up into a Wi-Fi access point. You bring up your phone, you log into 192.168.47.1, and you're in Sequoia. Okay, and then you tell it whether you want intervalometer or distance-based triggering or whatever. You tell it the ground sample distance that you want it at, and it triggers itself.
And, you know, it is a lot of information packed into kind of a lot of processing in a tiny little camera. You do need some airflow around. I wouldn't just embed it into some foam. It can heat up. So a bit of airflow around the camera.
I'd love to embed it in foam. I know exactly the foam I want to embed it in. I want to embed it in the back of a Parrot disco. No, come on.
Well, SenseFly makes a very equivalent product called EBSQ.
Really? But hang on. SenseFly product's about 10 times the price.
Yeah. Great software, great mission planning, great post-processing software. But you know, there's a lot of smart people. There's a lot of smart people out there working on a lot of brilliant stuff.
You know, the reason I like flying with Solo is that I can use Tower. You know, I use Tower or Mission Planner and can design a mission. And then I use my phone to just trigger the camera and I hit go. And so it's, you know, at $350 right now or whatever Solo is.
I mean, this wouldn't be the mission for a fixed-wing aircraft, but it does strike me that
what crushed that Sequoia tree was the orbits. Right, so the orbit smart shot is what crushed that Sequoia tree.
Yeah, and of course you can go out and do it again next week, the week after that, and it's going to be exactly the same place, and you go see it through. So let's say I'm a researcher at a university, and I've got a really compelling product that would give you, or concept that would give you great data. What sort of data would you like, and what sort of things could I do to get hold of one of those Sequoias to get it into my work?
Yeah, so this climate innovation grant is a 2-page proposal and then your academic CV. And so there we're relating it to kind of geography and mapping, multispectral data, and then as it relates to climate change. So that could be geography, it could be humanities, archaeology, etc. But we're trying to combine those different ideas. So we're looking for the best innovative idea across disciplines, preferably from strong candidates with a background in research, and they can go to edu.parrot.com. That's our educational page for Parrot/climate, and they can apply to the grant, and they can do that for the next 2 months. And that will include a Sequoia camera, Pix4D license, and likely a Solo or something equivalent with extra batteries, a full package, as well as consulting on our part to help you get up and running and talk about your particular project and how best to map it and analyze it. And then we're just looking to promote it to the rest of kind of the drone community, and we'd be happy to have them on SUAS News to talk about their projects. And so they can go there today, and that's across disciplines and across the world.
No, it's fantastic, and it's very close to my heart, and well done. I'm pretty sure I'm right in saying you guys are actually the first guys to come up with a proper environmental challenge. There hasn't been one yet. So well done and fair play to you. I'm very impressed.
Well, we learned a little bit from the master of the T3 challenges there.
Oh, not really. Not really at all. So we're very much in a festive 3DR ArduPilot, ArduCopter sort of mood then, really, aren't we? So that can bring us and swing us very nicely to speak to Joseph, who has who's rescued a project this last week and made it fly. You've been involved in the Airbus local motors challenge. I can't remember what the challenge was called in the grown-up world, and basically it was design something on paper and make it fly, and they couldn't make it fly, but you made it fly. Maybe you could tell us a bit more about that.
Yeah, no problem. Friend of a friend, introduced me to this project. I had actually seen the project when it began, which is when they announced the competition. And after reading through it, I said, I'm going to wait and see what everybody else kind of puts forth. I mean, at this point, I'd already built something at a subscale to what they wanted. It would just been larger, so I already know how to do it, right? But it would be interesting to see what everybody else thought. They ended up picking a winner or a series of winners, and they said, hey, let's take this concept, which is really all it was, and let's try to make it into an actual aircraft, not just an idea. And I think they're pretty deep in the project of building this aircraft, and they ended up making something that didn't really work too well, as far as I can tell. So with about 3 weeks left to go on the project, they contacted me and said, hey, we're scrambling here. What can you do? We heard you're the guy. And I said, all right, let me come down. And they're in Phoenix. Let me come down and see what you got. And when I showed up, basically, we had some pretty drawings, and we had some motors and propellers. And that's about it. And they said, what do we do? We'll leave it up to you. And I said, okay, here, we're going to make a list. There's a 5-stage process. And if you do everything on this list, whether I'm there or not, you have a, more than half, I would say greater than 50% chance of being successful. Some of the challenges were the timeline. So we basically, if we needed parts, we had 1 shot to order the part. If it wasn't the right part, well, we missed the November 30th deadline, sorry. So I said, okay, then, this is all, and they're open source, right? So this Local Motors company, their idea is to open source development of these projects, like crazy projects. They have the self-driving bus, they have this rally fighter, which is awesome, that you build yourself. And then their idea was, hey, let's build a drone, right? Which I hate saying that word, but that was their idea. Let's build a drone, because why not? Everybody else is doing it. So I guess they partnered with Airbus. They said, let's see what the open source community can come up with, and we'll make it a challenge so people actually submit to it. Now, yeah, there's a picture of it there. Yeah, so that's what they ended up building. They 3D printed a mold, they polished it out. So that was pretty impressive. The whole thing's carbon fiber. And we were desperately trying to fight the weight to keep it under 55 pounds to operate under the Part 107 regulation, which I have, my license. And that's basically the only way we could do this legally, besides flying it in their warehouse. One of the problems with this design, though, is that having that tail motor, or pusher motor, so far back to the rear of the aircraft that it creates 2 problems. One, it's hard to get a proper center of gravity, which of course has to be correct for the airfoil of the wing in fixed wing flight, and centered up between the quad motors. So the second problem is, though, even if that CG is correct, you have so much mass out there at the tail end that there's so much inertia once it gets moving, it takes more and more energy for it to make pitch corrections. So we're fighting that as well. But they basically said, we got it tuned as good as we thought we could. I had them actually build what they called the surrogate, which is basically like a stick figure version of this. That way, if they only had that 1 shell, and it was incredibly expensive to do all out of carbon fiber, we had this metal frame that they welded together, so we could test the electronics. We can test, we can test the gain sets, because we had no idea. So we did all this so that we knew we only had 1 shot to make this work. If this thing had crashed at any point during the gain tuning process, it would be basically game over for them. That's the end. So we did everything we could to mitigate risk and go like an iterative process so that we could have an okay chance of just being able to try to fly it, right? So I was impressed that we even got to that point of, hey, it's the last day, it might actually work. So then, like you asked me about the SpectreWorks guys earlier. So long story, we've been around this industry for so long. I personally was an intern with Jordi Munoz, who invented the RD pilot, back in the day. Right at the time, Chris Anderson decided to meet up with him. And I was basically his test pilot when he started his company out of his apartment building. So, his 3-year-old's pulling on my leg while I'm trying to do SMT soldering and putting it in the toaster oven, baking autopilots. I don't know if you guys have ever seen that, but I was there doing that with him. And then to see, all the way up until this point, it's very interesting, but I've met a lot of really talented people along the way. Me and John Cherbini work together. We know each other very well from a prior company, and same thing with the SpectreWorks guys. So back at 3D Robotics, when I came back to work there after going through all this, working for all the big aerospace companies in the United States on UAVs, I was tired of living in the middle of nowhere, and Jordi had a new office with 50 employees back in San Diego. And I said, San Diego sounds really nice right about now. So I started the flight operations division, which ended up turning into 3DR's version of the commercial services division. So we did a lot of rapid prototyping. I hired some of the best guys that I could find in my prior dealings in the industry, in the aerospace industry, to come in and really just have this rapid development team. It was basically the 3DR skunk works, if you will. And John Trevino was a big part of that as well, so he knows these guys. So basically 3 of the best engineers broke off after they decided to close down San Diego and change their focus a little bit. And same with me. I started my own little company, and I'm from LA, so that's where I am. The 3 of those guys, Brad, Jeremy, and Dan, started this company, SpectraWorks, out in Scottsdale. And I'm sure the only reason we're not one company is because they want to live in Arizona and I want to live in LA. But otherwise, we collaborate a lot on many projects. And them being local to Phoenix, I said, hey, you guys, like, I've been doing this all on my own. None of the other people there have any idea about autopilots, aircraft. They have a ton of other skill sets. But I said, I need someone to come in here and just make sure, just sanity check, like, we're only going to get one shot, right? So why don't you come in, have a look. And they came in on the last 2 days, a couple of them. They came in and said, yeah, I mean, it looks good. We tweaked it. I got it to about 85% or so within what I thought was acceptable. We ran into some problems. And I mean, like, the numbers, just to give you an example, like the D value on the roll, like, or the pitch rather, 0.017 is what I had, but it needed to be 0.015. And it took me like 3 hours to figure that out, because at 1.7, the whole aircraft was going to shake itself apart. And it took Brad and Jeremy to say, oh, that's a D oscillation at 8 hertz. So we know that, here we go. And then I was like, oh, wow, that fixed it. I'm so glad. And these guys worked, the local motors guys worked 12, 14, 16-hour days. The only day they took off, I think they made them leave on Thanksgiving, our past couple Thursdays. But other than that, for the last 3 weeks, they've been Saturday, Sunday, the whole time trying to finish this project. So just to see it get to that point of flying forward and coming back in one piece, amazingly. I mean, even I was surprised, okay? But I was very happy for them to have some level of success. And, they're really driven. And I think that's, with their drive and, some outside expertise, I think that was the way, that combination allowed them to have that success.
You made it win. Yeah, no, well done you, and well done to everybody involved. It brings up an interesting sort of point. The world is going separate lift thrust and or Vtol right now, or Tailsitter. There's 2 camps emerging, and the military seem to be siding with Tailsitters. Personally, I don't like them because they blow over. Does anybody have any? Look, John's smiling away. He's got some insight. Is there going to be a Tailsitter from Parrot if we unearth something here? Have we? What's everyone's thoughts? The difference between separate lift thrusts? Are we just carrying a quadcopter around or an octocopter around for an hour when we could have just been tail sitting? What's the way to do it? I
mean, I feel like I can answer this pretty well. I've built all the different kinds. This is something I've wanted to do forever. I mean, I grew up watching the X-Plane series on the Wings channel, if you guys remember that. Best TV show, like, ever. And they tried it. They tried Tailsitters. What was the problem? Well, the hardest part was they had to have a pilot in it, and it's really, really hard to land a Tailsitter if you're looking straight up at the sky. That was a huge problem. Now, of course, you don't need a pilot. Yes, you have the factor of crosswinds landing and, so on. Maybe they turn, instead of like turning into the wind, they turn, knife edge into the wind, essentially, to minimize that cross profile. Personally, after trying to do it myself and it's spectacularly failing, I decided that the vertical lift and separate lift and thrust method is superior for quite a lot of reasons. Even if you are considering the fact that you're carrying that weight, but maybe you're not carrying landing gear now, or maybe your support footprint, your logistical footprint is so much smaller, right? You don't need a runway, you don't need a catapult, you don't need a net. All these things that make UAV operations, like, limit them from being mobile. You can have a more efficient propeller if you have a separate lift and thrust, because you can take your time getting up to speed and have that propeller optimized for your cruise speed and so on. I mean, I've had great success with it. A lot of it the guys, there's a company called Latitude Engineering. I don't know if you're familiar, but I've known those guys for a long time as well, and helped and seen it. They're friends of mine. And the first one I made, I think, was actually just to spite those guys and say, hey, look what I can do with about $200, not, the $100,000. Of course, it wasn't as good, but, after seeing that aircraft fly in person, kind of narrowed down. There's a lot of key design features in some of these aircraft that are super important, not apparent unless you've actually tried to build one, because I don't think you could go buy a book on this stuff, right? There's nowhere to, there's nowhere to go get that information unless you try and fail, pretty much.
Yeah, no, definitely, and it's interesting. You can see a few things in that design that I would be interested with. I was going to ask Bruce, and he's disappeared, what his opinion on that. See, that was good at that. John, have you gotten any opinions on tailsitters and separate lift thrust?
It's something that I've always found very interesting, and one of the things that I know is incredibly difficult is transitioning from vertical to forward flight, and so with a let's say with a quad rotor or something like that. JB built a few vehicles that were amalgamations of quad rotors and fixed wing vehicles that would, take off and transition. And I think that, that's an incredibly difficult software problem to solve. And so, when I see something like the Medical Express Challenge, and I see Tridge solving that problem with a separate vertical thrust versus a separate forward thrust, that immediately tends to lean me towards that kind of solution, right? And then I see JB with the Micro Skywalker or the Micro Sky Hunter doing the same thing, and it works, right? I think it's a more efficient way of solving the problem right now. You see universities like TU Delft, who in the Medical Express Challenge did a bi-wing transitioning aircraft that was it's an amazing piece of engineering, and they actually used Slam Dunk on that, our new stereoscopic SLAM device, to pick their landing area. And they ran their own SLAM algorithms on it, and in a vertical mode were able to identify safe landing areas to land their bi-wing. Super interesting challenge, but come on, that is incredibly difficult to do.
Although, John, I have to disagree with you in terms of, so the best transitional vehicle on the market right now.
Swing! Come on. Have you guys seen the Swing yet?
I think it's awesome, man.
Let's go.
Right now for Christmas, you can fly it in the house.
I was going to say, I believe millions of them are making their way to with Santa, or Santa's boxing.
I gotta tell you, as somebody
Santa
who
hates them. There's so many Santa hates them.
Yeah, as somebody who loves the challenge of this kind of transitioning aircraft, the fact that Parrot, and I had nothing to do with this, right? But the fact that Parrot comes up with a vertical takeoff transitioning aircraft that's a quad rotor, effectively, that transitions into forward flight, it's amazing. It is so fun to fly, right? But it is such an incredibly difficult problem to solve that at scale, I feel like right now, if you're going to fly a 20-pound aircraft where you're trying to carry a payload, the safest way to do that is probably through quad rotor and then switching over to a forward thrust kind of model. But I'm not an aeronautical engineer. I've tried everything, and I know what's harder and what's easier, and it seems like the way we're solving the problem right now is the best way to solve the problem. We'll probably move into more kind of transitioning aircraft in the future, but even the efficiency in forward flight, I think, is also a big differentiator as well. So as soon as you shut off those quad motors and transition to standard forward flight, even with the drag, you're being much more efficient than you could be with a quad rotor in forward flight.
Yeah, absolutely. Now, Bruce, you had a solution there with the propeller on the front. Does it actually work with that quad?
Yeah, this is actually a Chinese product. It's called the Screamer, and it's a conventional, try and get it shot, conventional kind of mini quad, but it does have a thrust motor on the back, so you can hover, but for forward thrust, this provides a lot of extra power. And you can also do things like hover it this way on the thrust, on the forward propulsion motor, and just use these to stabilize.
Really?
Quite an interesting craft. Yeah, it's a really interesting craft. I don't think the market is really sort of looking for it, but it's fun to fly, and it's a good cost.
It seems that the market's not looking for it. That's probably the most incisive comment about it. But can it really hover on that front prop? Can it tails it on it?
I've been practicing, so I hope to post a video sometime in the next week or so showing this thing hovering and pirouetting in a vertical plane like this. And it's not easy, but it is fun.
Wow, I never would have thought that would have had the power just on that propeller. That's crazy. That's absolutely crazy.
So Gary, I have brought mine out so you can show you guys. So that's pretty much it, man. And I always, I'm like, simplicity is best, especially with repeated operations. There's so many technical challenges. And one last comment. I remember, I won't name names, but I was given this comment. The Vtol is a spork of a UAV. It's not really good at being a fork, and it's not really good at being a knife. And I said, that's very interesting, but how many sporks have they sold? Ever?
I might even have been accused of saying that, I think. But we've very much hung our hat with the Aerovol Flex rotor, because that's why it's in our logo, because it's just an amazing thing. It's just amazing, and that is
so sweet. I love watching that thing, and it's been around for what, 3 years now, something like that.
Yeah, maybe 4 or 5 even. But it's just I haven't got the picture, but they've got show off moment. But they've got they're putting out a great picture with our sticker there, and then out of focus in the background there's the Flex. It's in their ground control station, so I'm quite proud that one of our stickers is there. But that's an amazing thing, and not a lot of people know about it. Really, I think you've got to be a special kind of UAS nerd to know about it, and I see big things for that platform. But those guys are just amazeballs. They are another level. They're just another level. They really, really are. Look, we've already gone over the hour, but we need to go just run through an interesting one. I think the TFR at Standing Rock. Have you had any time to think about that anymore? Our tame lawyer, Jonathan.
Yes.
No. Oh, no. Why do I do that every time? So what have you thought, Jonathan?
About it.
Oh, bloody hell. Bloody lawyers. Unfortunately, Loretta's not joining us. She's just got back in from China, and we're hoping to get someone else from there. But they relented in the end, didn't they? Didn't the FAA let the media in there, media drones?
There was one waiver that was granted to allow a journalist to fly in the TFR, and that's all I know so far.
And is there still the general thought that it was a bad thing for the FAA to do that?
I mean, some people say that. Some people might not. I mean, law enforcement. It's a general protocol for law enforcement or first responders, any of those guys to kind of call in these TFRs when there's a certain situation. I don't really know the motives for the guys doing it in the background. Whether they had they wanted to keep people out, or there was just good intentions. I don't know. So, I mean, there's just a lot to say on both sides of that issue. It's a very complicated issue. There were other TFRs that could have been called in. I mean, there's primarily 8 regulations that could have been cited for a TFR. Well, really not a couple. There's 8 total TFRs. And then of the 91-137, there's 3 different versions of it. And they cited A1, which is the most restrictive. So I don't really know what the motive was behind the scenes. I don't know what the FAA was thinking. I don't know why they chose that. But there have been a lot of people that have been very they have become upset because of that. So
yeah, I know.
The door just opened up all creepy, I'm expecting a murder to come out and get you all of a sudden. The FAA is now about to get you because you asked that question. It's so.
And it's real time as well. It's amazing how that works, isn't it? It's absolutely amazing. It's
Hey,
quite extraordinary.
just a real quick question, and just off the cuff, because you guys, we have the right people on the line here. I mean, do you guys think there's going to be any repercussions from the ones that were brought down during that event?
There could be.
Yeah, I think that you won't get an answer out of him.
Come on, you gotta ask. You gotta ask, because you sit there as, okay, so I took I passed my FAA Part 107 exam, and you know that you're treated as kind of a general aircraft, and you're not supposed to be shot down, right? And so the fact that you have all of this live video of guys, bringing beanbags up there and bringing stuff down, it seems to be
it's one rule for one and one rule for another, almost, isn't it? It's if there's regulation, then it has to apply equally all the way across. You can't just chop and change as required.
Yeah, interesting discussion, at least.
Yeah, there's a lot that can be said about interfering with manned aircraft. I'm actually working on an article on major issues with just jamming drones, because shooting at a drone is in the same issue of how do you actually counter drones, right? You can shoot them down, you can catch them with the net, you can jam them. I mean, how many different ways can you mess with them? You can just completely jam the signal. You can spoof the GPS signal. You can hack in through the unencrypted controller, like all of the DJIs out there. So, I mean, there are multiple ways you can do it. Problem is pretty much every one of them has some type of criminal element to it. There's a lot of laws that prohibit that type of stuff.
What if you were to modify something or disrupt it, but then that causes an accident, right? So how do you deal with that?
See, that gets into the really good discussion, because let's say you shoot down the drone and the drone crashes into someone else. That individual who was hurt can potentially go after the drone owner. It can go after the guy who shot down the drone, saying, well, one, you were being actually criminal in shooting down the aircraft, so therefore you actually violated your duty, your standard of care, because really these statutes, these federal aviation regulations are duties, standards of care. Like, don't shoot down the aircraft. That's not how normal people behave. So you didn't do that, therefore you committed negligence, and you were the proximate cause of this injury, therefore we're going to sue your pants off. So when you do criminal activity or illegal activity, that's where it gets very problematic. When you open yourself actually more up to liability, because you're violating that standard of care, especially when you fall into that scope of what that standard of care was designed to protect. So all these people that are hiring illegal operators that are going out and crashing their drones, well, you do have some potential lawsuits against them, or you can sue them. I mean, there's a lot of liability issues in this area.
And aren't we dealing with the organisation that Hobby King came up against, the FCC, which in some ways has a bigger set than the FAA and ability to fine and sort stuff out. Radio regulatory authorities tend to be powerful wherever you are in the world.
Right. I'm scared of the FCC more than I am actually the FAA. They scare me. And then if DOJ wants to get involved in actually trying to prosecute the criminal go after the criminal statutes, there's a lot of people doing a lot of things they shouldn't be doing, and it'll be interesting to see where we are 6 months from now and who's in trouble and who's not.
I saw at Farnborough there was a chap with a anti-drone system, super radar, solid state stuff. It was all very, very fancy, and of course, whenever you do anything fancy, you have to put it in a very fancy ground control station. And in the ground control station, they had marked 2.4, 5.8, 72, 35. They had all the buttons all marked down on this thing. So I said to him very innocently, I said, "Hey, chap, what is that? Someone's printer's going or something."
Oh, the 3D printer.
I was going to say, and suddenly something was 3D printed.
It's a 3D printed airplane, actually.
Oh, we can talk about that. I was utterly wrong about those things, but anyway. So yeah, I said to this chap, well, what does that all mean down there then? Why 5.8, 2.4, and well, I said, well, I can't really tell you about that. He said, well, what happens if I was to press that button there on? Well, no, I mean, so I said, well, so you're going to jam and disrupt a command and control frequency, and those happen to be all the popular frequencies. When we've detected, and it was amazing, they had all this thing tracking aircraft and all that. I said, well, where's it going to fall? What, you're going to shoot it down, but what's it going to hit? And who has the authority then? It's like, I don't know what it's like, but it's just, yeah, there's all sorts of rights, roles, and responsibilities, isn't there? But there is equipment. I don't think people realize the equipment is out there to do it now, and people are beginning to sell of it. Some of it will work, some of it will be nonsense. But yeah, it's I don't know when we're going to get the first instance of that, but it's going to happen soon, I think. Anyone else got any thoughts? No. So let's go to that 3D wish. Sorry, John. Go on, John.
I think shooting projectiles in the air to bring down drones is a bad idea, right?
Well, it's radio, isn't it? It's using RF to do it, and that's sort of kind of more insidious in some ways. Yeah, I don't know. Bruce, have you got any thoughts on that? You're a radio man.
Just going to mute my mic. Yeah, it does hold a lot of regulatory issues because most countries regulate against such emissions unless you've got special exemptions. So anyone using that who didn't have the necessary legal exemptions would find themselves in more hot water than the drone operator. And also, I know it's a miss amount on that one you're talking about. There's 433 and 868. There's quite a few frequencies now being used for drone control, especially for longer range stuff. So, and also, if it only transmits on one at a time, it's pretty trivial to create a backup system where you have a receiver on 2.4 and on 72 and one on 433, so that as the gun shoots out one part of the band, the other part of the band takes over, and if for every countermeasure, countermeasure.
Well, there's one thing I think people don't consider when they look at these products. Like, yes, can you jam the command and control frequency? Of course, but at the same time, could I take off all the receiving antennas and program the mission beforehand and then just say go? Of course I could. So at that point, the only thing you have left is GPS, which, yeah, it could be jammed. I think it's the FCC would get very, very upset about jamming GPS because you can interfere with safety systems and full-scale aircraft and so on. But
you can buy those jammers off the shelf. They're off the shelf out of China.
They're legal. You can't have them or operate them. I mean, I think you can have them. You just can't operate them, or otherwise the FCC comes in their black helicopters or whatever. But basically,
they can't because the GPS doesn't work. But
well, even that. But they could. But there's way to do inertial estimation as well. So I mean, at some point, it'll be cat and mouse. But like they think they're stopping this thing. Yes, of course, if it's under manual control, right, and you're actively controlling it, requires your guidance. But if you just it's totally capable of doing it on its own, and I think that's kind of, no one's really talking about that.
And I have remembered, I do know that they did use the system in anger, and I know where they used it as well. They used it at Lasham Airfield in southern England, and they used it in the filming of the last Star Wars movie, and they shot a few Phantoms out of the way that were coming over the Star Wars thing at Lasham. And that's when they knew there was a new Darth Vader helmet or something like that. Anyway, so I know they've been used in anger down there. So you're 3D printing an airplane, that's beautiful, because today I posted, because I was utterly wrong. I sort of said that'll never work because it's always going to be too heavy. It's always going to be this. It's always going to be that. And there's some beautiful 3D printed airplanes out there now. So what are you printing?
So that's not as spectacular as what you can do, but it's a glider, right? So this is after I got to thinking about it. I was like, someone's already done this. Let me try to print it. I'm trying to rip it off, but the plate's still too hot. But yeah, I mean, if you get down to these incredibly complex structures like airplanes, they're difficult to create with other material. The 3D printer is perfect for that. All these complex support structures and so on. So,
did you see the flight test of the P-38 that came out from those guys? I mean, that's just a piece. It's a beautiful thing. It's a beautiful thing.
Yeah, it's awesome. I've seen it. I've seen one of those in person. And in fact, I think I have the STL files for that. So I'm going to maybe try printing it. But you can see like the rib spars, they're at 45 degrees. So it can be printed
with the printer and not fall over. So you have to change the internal structure of it. But I mean, this is something they've been trying to do for years. I think I remember the company, they gave us one, right? Remember, John? So they could print at like 1/60,000th or something crazy of an inch. And it's like a skin, like it's like literally like fat, like the size sheet of paper, like thinner than that, you know? So I think totally, yeah, you could print the whole aircraft, including the aerodynamic surfaces.
Yeah, well, the Southampton one does that. It's everything. There's aerodynamic surfaces are there. There's no, and it clicks together. All the bits click together, and that's very, very cool. And there's been a jet one. There's been all sorts of ones out there. But it strikes me: are we entering a new age where the manufacturer changes the airframe design and it just sends the file off to the right person somewhere on the other side of the world, and they make the modification and print it away? It's going to be a different relationship between the manufacturer and the end user, which is very, very interesting, I think.
Yeah, I mean, I think sometimes the way an aircraft ends up looking is not based upon aerodynamics 100%. Like, it's based upon, like, can you actually construct this and make it structurally sound? And there was a project I think we were talking about just earlier where, having, an inverted, like, gull wing looks awesome, but how do you make that so it doesn't break in half, when you apply a load to it, versus just a single spar through the entire airplane? But now with 3D, if you were to 3D print it, like, yeah, maybe you can do some trickery in the internal structures, and you could have some very unique looking aircraft and these advanced, manufacturing techniques. You'll be less limited potentially.
Well, of course, Bruce is part of the New Zealand Skunk Works, and they iterate many different designs on a weekly basis, and are coming up with some groundbreaking canards and uncanards and all sorts of other things, and pushing forward the boundaries of aviation.
That's awesome.
One piece of balsa at a time, isn't it, Bruce?
Yeah, or foam, and we've got our pilot's chair as well, which is adding a new reality to flying remotely piloted vehicles. We should have a new version of that going just after Christmas.
Oh dear, that thing does look awful. But anyway, moving on very swiftly. Stewie, I think over in the UK you have some new advice, regulatory advice from NATS, the National Air Traffic Service.
Yeah, it was only a couple of days ago they released a new app on iOS and Android. Basically, it's a sort of a safe to fly type app where it comes up with your geolocation and comes up with a really nice, really simple map sort of overlay, red, oranges, greens area where it's good to fly, as well as ATZ information, restrictive air zone information. Really dead simple, free to download. Yeah, absolutely all for it.
And in the UK, I can't remember, what would happen if you had to fly near an airfield over there?
Well, quite simple, actually. I've had quite a bit of experience in this in the last sort of couple of weeks. I listen quick phone calls to TAR, I let them know to the senior psycho, let them know what mischief you want to be up to, as long as you seem to sort of know what you're talking about, allegedly or not. Yeah, okay, boy, you carry on, The majority of the UK I tend to sort of give them around about sort of 48 hours, 50 odd hours notice and say, hey, look, in 3 days time I'm going to be doing this. And they usually say, okay, just give us a quick phone call on the morning of. And my normal protocol is I give them a quick call, maybe sort of 10 or 15 minutes before lift, and then just explain what I'm doing. Then a quick phone call, then say mission complete. And up to now, I've been working in some pretty sort of close airspaces, really, to be fair. Although I did have a bit of a one last week, actually. I was operating into a very active military air traffic zone, or an area of intense aircraft activity. Trying to get through to London military was an absolute bloody nightmare. And in the end, I got through to some Waller who said, I'm not interested, mate. Oh okay, then. Fair enough.
Imagine. Yeah, I'm laughing because I used to work at the alternative one, the Scottish Air Traffic Control Centre, and that not interested person would have been me, and I wouldn't have been answering the phone. So that's why I'm laughing, because I know that exactly. Yes, shut up. I'm drinking my coffee and eating biscuits. Now, please go away. Yeah. Yes.
So in the end, I just used a bit of common sense, and I contacted the known high sort of military activity fields and gave those boys a quick call, you know. And they sort of appreciated the phone calls. However, they said, right, okay, duly noted. Thanks ever so much indeed. Yeah, we've got some missions planned for later on. And there I am operating at, what, 50, 60 meters or so. And there was 2 fast jets, not maybe 500 feet away at me, going zipping through at 150 feet AGL, you know. I'm thinking that was a waste of a phone call then, wasn't it?
Well, yeah, and they once the guys are in the low-level system, they wouldn't have been able to notify them anyway. They would have to told them before they dropped into low level. So NOTAM the day before or something like that probably would have been the way to go with that one.
But they'd had the notice sort of 3 or 4 days previously. That's the point I was making.
No, but they wouldn't have issued a NOTAM based on your telephone call.
No. Agreed.
Yeah, that would be the thing.
So anyway, go back to the NATS app thing. Real heavy, nice bit of kit to use, to be fair. And that seems to be having a really good old push now, trying to promote sort of safety, which is good.
No, it is good. It is good. All right, look, we've pushed well over the hours, 1 hour and 23 now. Amazing guests. Thank you so very, very much for taking the time to join us. Bruce and Dr. Greg and John and Joseph and Stu. No, thank you very, very much for your time. Lots of valuable stuff here. And hopefully we can get you back again and hear more about how the Parrot initiative goes, and see if the what's it called? Local motors, isn't it? That's it. Local motors thing keeps working. And of course, Jonathan, our lawyer, just never answers anything anyway. What's the point? Just smiles and pleads the fifth or whatever it is. There you go. You see, look, he has it on tap. Just as on tap. No, thanks, guys. Let's do it again next week, and then the week after that, on the 20th, I think we should have a prediction program for 2017. See what's going to come. So let's all start thinking about that. Thanks, guys. We'll speak to you next week.
Good night.
Thank you, Gary. Thanks, everybody.
Bye.
See you.